In lesson 9.3, we will perform reflections. We will reflect a figure in any given line. In the past, we've only reflected figures over the X or Y axis. Also, please note, if you are watching this video for a geometry class other than my geometry class, in Geometry Honors, I know the book talks about and has a lesson on matrices and includes matrices in each of these sections. I do not teach matrices in my class as they are not a geometry or a geometry honors standard. In the state of Florida, they do not fall in our standards until pre-calculus classes. So they are not included here. For today's warm-up, the first problem is the y-axis is the perpendicular bisector of AB. If point A is at -3, 5, what is the location of B? So you have to kind of picture this here. You have an X and a Y axis. A is at -3, 5. So that's 3 spaces from the Y axis. If I have AB that's going from point A over to point B, and it's 3 spaces from this point to the y-axis, it would then be another 3 from this point to the y-axis, and the location of B would be 3, 5. What is the slope of the segment with endpoints -7, 4 and 4, -7? So we're going to subtract the y values. 4 minus -7 is the same as 4 plus 7, which is 11. And -7 minus 4 is -11. So your answer is 11 over -11, or -1 is what this would simplify to. Is a transformation that uses a line like a mirror to reflect an image. The mirror line is called the line of reflection. A reflection in a line M maps every point P in the plane to a point P that's read as P prime, so that every point one of the following properties is true. If P is not on M, then M is the perpendicular bisector of P. You can see that drawn there. If P is on M, then P and P prime are going to have the same value. So if the point is on the line of reflection, basically it doesn't reflect. And if the point is not on the line of reflection, then the line that you could draw from the original point to the reflected point, you could draw a line connecting those, a line segment connecting those, and that segment would be broken or bisected perpendicularly by the line of reflection. Let's see how this works. So the vertices of A, B, C are 1, 3, B is 5, 2, and C is 2, 1. In the past, we have always reflected over the X or the Y axis. Now they want us to reflect over this line N. So basically, point A is 2 units to the left of N. So its reflection, A prime, is 2 units to the right. B prime, okay, so is 2 units left. This is a little misleading here. So the original B is 2, oh, here we go. The original B is 2 units to the right. So B prime is 2 units to the left. And the original C is 1 unit to the left, so the new C is 1 unit to the right. It's what we've done before, but now we're not using an X or a Y axis. We're using another line that they give us to reflect. Okay, we can also do this horizontally. So here we're given the line Y equals what? So since A is 2 units above line M, the A prime will be 2 units below. Since B is 1 unit above the line of reflection, then B prime will be 1 unit below. And as we said earlier, since C is on the line of reflection, it will stay on the line of reflection. Look at how to do this. They've asked us to graph a reflection of A, B, C from example 1 at Y equals 4. So let's look back at example 1. Okay. So this is the same triangle there, this blue triangle, and they want us to reflect it at Y equals 4. So 1, 2, 3, 4. This would be our new line of reflection. So our A prime, rather than being 1 unit below, would be 1 unit up. So our A prime would now be at 1, 1, 2, 3, 4, 5. Our B was 2 units below. It'll now be 2 units up. Okay? And that would be 1, 2, 3, 4, 5. So it'll still be at 5 on the x-axis. But for the y-axis, it will go 2 up. It'll move a total of 4. So this is 2, 3, 4, 5, 6. I know this pen isn't working well. So that's at 5, 6. And our new C was 1, 2, 3 units below the line. It's now going to be 3 units above the line. So if this line is at 4, it's going to be up at 7. So it's still going to have the same x value. And this is where we would draw the new triangle. I think in this example, when I pull this away, you can better see this drawn out. So A, as we said, is at 1, 1, 2, 3, 4, 5. C is at 2, 1, 2, 3, 4, 5, 6, 7. And B is at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. For guided practice 2, we're going to graph with a reflection of x equals -3. So if you want, pause this for a minute, try and do your answer, and then I'll pull this away and go through this. So the original triangle here, and this is a little confusing because they've drawn it like on skipping by 2s here. So this is the original axis. A was at 1, 1, 2, 3. So now they wanted the line at x -3. So since this was at 1, let's go back and just make sure we have those points because it's hard to jump around. A was originally at 1, 5. So now it's still going to be up 5. But since 1 is 4 units from -3, it's going to be 4 more units on the other side from -3, so -7. So this would have been 2, 4, 6, 7. Okay, B was originally at 2, 4, 5, up 2. So it is still going to be at 2, because we're changing over the x-axis. But instead, since our line of reflection is at -3, 5 is 8 spaces from -3. So -3 minus another 8 spaces is -11. Pen here is not working. It's hard to see this. So this is at 2, 4, 6, 8, 10, 11. We could have counted that, but I want you to see how to do it if you don't have graph paper. And C was originally at 2, 1. So it is still going to be at 1 on the y-axis. But instead of being, so 2 to -3 is 5 units. So 5 units the other way is -8. Next problem, because I think this got a little confusing. We're going to be graphing this with a reflection over the y-axis. So I'm going to try and do this without graphing just to show you how you're eventually going to do this. So since we're graphing over y equals 2, if we're at 1, 3, we're graphing over a horizontal line. So our x value is going to stay the same. We were 1 unit above the horizontal line, so now we're going to be 1 unit below the horizontal line. Remember, since we're reflecting over y, our x values don't change. So y is 2, we're on the line, that stays the same place. And for the last point, we don't change our x value. Our 1 is 1 below the line of reflection, so now it's going to move to 1 above the reflection. Okay, so you can see our A prime is now at 1, 1. Our B did not change, and our C flipped from 2, 1 to 2, 2. So I want you to be able to do it on graph paper, but I want you to be able to understand, like I tried to show you in the guided practice number 3, how these things are going to switch around. When you're reflecting over the y-axis, the x values stay the same, the y's change. When you're reflecting over the x value, then the y's stay the same and the x's are what change. So we can use some coordinate rules to find the images of points reflected in 4 special lines. So if we reflect something over the x-axis, as I said, the x-axis, so the x value doesn't change. And the b value is going to be the opposite of what it was. That's only when we actually reflect over that x-axis. If we reflect over the y-axis, okay, then our y value doesn't change and our a value becomes the opposite. Some interesting things also happen, and if you remember your parent functions from algebra. So if I have the equation y equals x, that should be a straight line, but that's what happens. So if you have a point at A, B, those coordinates reflect. So let's say you had 2, 1, it's going to switch to 1, 2. So it would be like 2, 1 becomes 1, 2. Or -2, -5 would become -5, -2. Now, let's say if you reflect over the line, y is equal to -x. There. Sorry, that's not straight. But that's basically that line. That's what it should be, a straight line. Now you're going to have A and B, and you're going to go to their negatives. So let's say you had here -3, 4. When you reflect it, you're going to get -4, -3. So these numbers change, they switch order, and you have their negative, their opposite value. So there's some rules you can start trying to memorize to help you a little bit with reflections and not having to graph every single thing to understand where it's going to be. They want us to graph a reflection in y equals x. So remember, that's this orange line here. And the rule for y equals x is that the coordinates are going to switch. So the endpoints of FG are -1, 2, and 1, 2. Reflect the segment in line y equals x. So my F prime is going to be 2, -1, and my G prime is going to be 2, 1. So let's see how this looks here. So there we go. There's our line. So FG and GF. So let's look at our original points. FG was -1, 2, and 1, 2. -1, 2 becomes 2, -1. And 1, 2 becomes 2, 1. So now in example 3, they want us to reflect in y equals x. So we have that same original line of FG. Remember our rule for graphing a reflection in y equals x is that the A and the B values switch and you get the opposites. So instead of having a -1 here in your x value, the opposite of A is 1, and that becomes your y value. And for 2 in B, your x value, and your y value for F becomes your x value for the F prime. And remember that you have to adjust the negative sign. So -1, 2 following this format becomes -2, 1. And 1, 2 following this format, basically the opposites inverted, becomes -2, 1. You graph those, you have the original line, and you have the new image. Graph ABC with vertices of 1, 3, 4, 4, and 3, 1. They want us to reflect it over y equals x, y equals -x, and y equals x. So first thing we have to do is remember our rules here. For y equals x, you're going to take A, B, and turn it into negative b, negative a. So this 1, 3 is going to become negative 3, negative 1. B is going to become negative 4, negative 4. And C is going to become negative 1, negative 3. Now, for your y equals x, you're just going to take your A and your B value and switch them, but no negatives. So, for this one, y equals x. 1, 3 is going to be 3, 1. 4, 4 is going to be 4, 4. And 3, 1 is going to be 1, 3. Now that you've done all that, you can go ahead and graph these. So here's your original 1, 3, 4, 4, 3, 1. When you graphed it in y equals negative x, A is at negative 3, negative 1, as we expected it would be. B is at negative 4, negative 4. And C is at negative 1, negative 3. For this next one, where we graphed it here, so your original A was at 1, 3. Your new A is at 3, 1, which is where your original C was, and your new C is at 1, 3. So in this example, your figure is reflected what we call onto itself. It's still laying in the exact same space, but the A vertice and the C vertice have flip-flopped. In example 3, verify that FF is perpendicular to y equals x. Okay? So in example 3, FF, so that would be this line here, is perpendicular. So what we would do is we would just find the slope of each of these. This slope has a slope up 1 over 1, the slope of 1. This point, if we go from any 2 points on the slope, has a slope of down 1 over 1, or negative 1. 1 and negative 1 are negative reciprocals, so they are perpendicular. And that's what we just did. So we've talked about this before. Recall that the image of a translation is congruent to the original figure. The same is true of a reflection. A reflection is an isometry. An isometry just means that they're going to be congruent. And we talked about that in an earlier chapter. So in order to prove the theorem, so we're just going to go through this, you need to show that a reflection preserves the length of a segment. And there's a number of different cases here. So for P and Q, if they're on the same side of the line of reflection, they're still congruent when they reflect. Case 2, P is on one side and Q is on the opposite side. And when you reflect them, they're still congruent. Case 3, P lies on M and PQ is not perpendicular to M. And case 4, Q lies on M, or one of the points lies on M, and the line segment is perpendicular. We do not need to actually go through and prove each of these theorems. We know we're going to accept that they are true. So now let's find a minimum distance. You are going to buy books. Your friend is going to buy CDs. Books and CDs. Where should you park to minimize the distance you will walk? Now, most of you know you would just park in the middle. So in this problem, yes, in the real world, you would kind of just eyeball where the center was, but we're going to almost do a construction to get the exact point. So we're going to take point B and we're going to reflect it. So this is the first thing they're doing. They're reflecting this in over line M to get the basically what would be the perpendicular bisector. You could draw a segment here that would be a perpendicular line, not a bisector, but a perpendicular line from B to B1 is perpendicular to line M. I'm going to label this here. Then you're going to draw a line. So step 2 is drawing this line. Okay? Where line AB intersects M is point C. This is the shortest distance from A to B. And BC is going to be the same. B prime is going to be the same as, B prime C is going to be the same as BC. So point C, so basically like where these two lines would intersect, is going to be the shortest point. In problem 6, guided practice 6, they ask you to do this same thing, reflecting over A. And I think you're going to see, you're going to get the same thing. So basically what you would do there is you would be, let me clear these annotations. You would basically be taking point A. You would be drawing A prime as the reflection. In that example, these don't exist. Then you would draw a line from B to A prime. And where that point intersected, which is C, would be the same distance there. Daily homework quiz. Graph the polygon and its reflection in the given line. So you're going to graph this over y equals 1. Let's look at the solution so that you have this whole graph here. So the original point, this was the original point, the original A would have been at -2, 1. This is your, it's hard to tell this. This is your original x-axis. This is your original y-axis. So at -2, 1. Then your original B is at 1, 4. Your original C is at 3, 1. So I'm going to draw these points. And your original D is at 2, -1. Some of the time it's hard to kind of just figure out on when they show you this already done where your original graph is and where your new graph is. So you're reflecting over y equals 1. A is already at y equals 1 and C is already at y equals 1. So those points don't change. B, the y value stays the same, the x value stays the same because we're reflecting over y. Instead of being 3 above the line, because this is the line you're reflecting over, you're now 3 below the line. And for D, instead of being your original D was 2 spaces below this line. This is the line of reflection. It's now 2 spaces above. So once again, when you're reflecting over y, x value doesn't change. For our next problem, graphing the polygon and its reflection in the given line, they're reflecting y equals x. So if you remember, just a rough sketch here. That's your coordinate grid. That's your XY axis. And to make this a little bit more exact, this is your line y equals x. So on this case, this is where you have that format of A, B. Everything is going to switch. So I find it easier, once you kind of know these rules, to find the new points and then just graph them. So your new P is going to be 2, -2. Your new Q is going to be 4, 3. And your new R is going to be 1, 4. So we graphed the original, which was P was -2, 2. Q was 3, 4. And R is 4, 1. Now for our reflections over this line. P is now going to be at 2, -2. Q is now going to be at 4, 3. And the new R prime is going to be at 1, 4. So I can graph those points and connect it. Yes, you can kind of try to eyeball where this point is and try and imagine, if you folded the paper in half or made like a mirror line, where the new point would be. And that is a lot of what we do when we're just reflecting over the X or the Y axis. As these get more complicated though, I want you need to be able to understand the rules and really be able to come up with these points without having to have the visual of the graph. And matrices we do not do in Geometry Honors. We do not do matrices in Geometry Honors. But now you can go through